The Cascadia Megaquake isn't a question of if, it's when. Scientists have spent decades piecing together the evidence, and what they found is clear. The Pacific Northwest is sitting on a ticking time bomb. It's a real danger and a fascinating story. In this long play video, we've collected everything you need to know: the history, the science, and the keys to surviving America's lurking disaster. In the Pacific Northwest, a slow-motion collision of tectonic plates along the Cascadia Subduction Zone has been building tension for over 320 years. And when that tension is released, the resulting earthquake is likely to be as large as a magnitude 9. That will be 45 times more powerful than California's most destructive quake in 1906, and the consequences defy imagination. This megathrust earthquake is predicted to be so significant, locals simply call it the Big One. And scientists estimate that it has an alarming 37% chance of occurring within the next 50 years. In this episode, we'll learn just how this megaquake will impact our cities and find out what's being done to prepare our infrastructure and learn some invaluable lessons about how to make a plan for when the big one hits. Subduction zone earthquakes often cause sudden movement and changes on the ocean floor, triggering tsunamis large enough to completely wipe coastal communities off the map. Remember the Fukushima power plant disaster? In 2011, Japan was hit by a magnitude 9 earthquake, similar to what we're anticipating here on the West Coast, and it unleashed a tsunami of devastating proportions. Chris Goldfinger is a geologist in Oregon who studies earthquakes, and he happened to be in Japan when the quake hit. I asked him to tell me about his experience.
We went outside and just watched the buildings moving, the flagpoles whipping, and it just felt like the whole earth had turned to liquid, and yet you could feel this grinding plate underneath us. And as we watched it, though, we knew that northeast Japan wasn't expected to have anything bigger than about an 8.4. But when it hit 3 minutes and went past 3 minutes, we knew that was wrong. We were going, this is a 9. It has to be a 9. That's what it takes, 3 minutes.
Because of a long history of earthquakes, Japan was so well prepared that this megaquake destroyed a relatively small number of buildings, but they just didn't expect the size of the tsunami that followed. Allison Perch, an engineer from Oregon, visited in the aftermath.
It toppled most of their tsunami walls, inundated huge amounts of the Japan coastline. It killed 16,000 people. And we were there 6 to 8 weeks after the tsunami, going and standing there and smelling the fish smell. And you can imagine where the water went because you can see the water lines on the trees on the hills around it. You can see the pieces of people's lives strewn around. So as an Oregonian, that's really hard, knowing that that's what our coastline's gonna look like.
And while the Tohoku quake in Japan was the costliest natural disaster in the world's history, here on the West Coast of the United States, we're nowhere near as prepared as Japan was for this kind of disaster.
If that had been Cascadia and I'd been at work, my building would have collapsed. There's no question about it. I might have gotten out, I might not, but it would be gone. Everybody thought Cascadia was aseismic, meaning no earthquakes, because historically that's what it was. It was dead silent. And then the first evidence was discovered in the early to mid-'80s, and realized that we just happened to be sitting in a quiet spot.
The Cascadia Subduction Zone is a 600-mile fault that runs from Northern California up to British Columbia. Over the last 10,000 years, geologic records show that there have been 41 subduction quakes here, which averages out to about 1 every 250 years. The last one came in the year 1700. That's 321 years ago. Since then, tension along the subduction zone has been slowly building as the Juan de Fuca plate steadily pushes into and under the North American plate. The plate edge continues to gradually bend and buckle, and one day it'll release that tension, causing up to 5 minutes of violent shaking and triggering an immense tsunami that could reach 100 feet in some areas.
If you were looking at a bird's eye view of Portland or Seattle, very soon after shaking started, bridges and other longer infrastructure are going to be warping and falling off their foundations. You would see unreinforced masonry buildings start to collapse. This is where 95% of Oregon and Southwest Washington's fuel is brought in and stored. These tanks will deform, they'll spill. Any type of spark or metal hitting each other could also start a fire. The Cascadia Subduction Zone earthquake is going to be one of the worst disasters America has ever seen.
Officials in Portland, Oregon created this animation showing what they predict one of the busiest bridges in the Northwest will look like. And it's not pretty. aftermath of the quake, survivors along the coastline in towns like Seaside, Oregon will have as little as 20 minutes to evacuate before the massive tsunami hits.
In a place like Seaside, what we need to do is get from here up to the hills right back there. It's a very straight path. It's not that far. It's a very doable evacuation, but there's a problem here because there's no way to get there without crossing one of these bridges. The bridges were built before plate tectonics, so we've got no retrofitting at all. If these bridges go down, people trying to evacuate are going to have a problem. They're going to have to swim the river and then continue evacuating up the hill.
To get an idea of just how risky this situation is, Chris actually flew our camera person over Seaside in his acrobatic plane.
As we're flying over Seaside, you can see how low elevation the town is. The ground doesn't really rise much until you get well on the other side of the highway. Pretty much everything on the west side of Highway 101 is pretty likely to be inundated. I mean, I came home from Japan feeling optimistic about it, but at the same time, I look around at the Pacific Northwest and I can see just visually that, yeah, we are 1,000 years behind, and this is not going to be easy to catch up.
But officials in the Northwest are getting started. Portland is currently reviewing options to build a new Burnside Bridge to serve as a lifeline after the quake. And all new structures are being built up to earthquake standards. Still, the vast majority of homes in the region are not ready for earthquakes of this magnitude and aren't even bolted to their foundations. Michael Weber is a contractor specializing in retrofitting homes to make them more likely to survive an earthquake.
So this house was built in 1911. There really wasn't a building code back then. This house is sitting on the foundation through the grace of gravity. We're going to rectify that. We're going to collect those earthquake loads and get them into the foundation to prevent the house from moving off the foundation. So the vast majority of our work takes place underneath the house. So in this case, the basement. All right, so this is a special order plywood that's designed for earthquake loads. And it's going to install like this to get those loads from this beam up here into the sill plate down here. And then we'll install this side plate and we'll continue that load path into the foundation.
The most important retrofit is strengthening the connection from the walls to the floors and to the foundation. Some homes are simple to retrofit and it's possible to do it yourself, but others are very complicated, so it's worth having a professional take a look if you live in an earthquake-prone area. And there's a lot you can do without construction skills, like making sure tall furniture, heavy wall decorations, appliances, and even electronics like televisions are securely attached to the wall so they don't fall on people during a quake. Mark Ginsberg is a Portland NET, or Neighborhood Emergency Team leader, and has been preparing for the big one for over a decade. Despite living and breathing disaster preparedness, Mark surprisingly doesn't seem too overwhelmed by the inevitable earthquake.
It's not the thing that keeps me up at night. Because I know that I can't control it. I understand where I live and I understand that that's a possible risk. But I also know that if I do some preparedness work and if I do trainings, this year I redid my first aid and AED trainings, those are the parts that I can do and that I can control. There's your house and the physical things, there's the knowledge, and there's a plan. But I think having the things that you as a family or a household need to just be independent for a little while is really crucial.
Here are Mark's top 5 most important things to keep in your home or garage when preparing for the big one.
Shelf-stable food, water, 1 gallon per person per day. Good fire extinguishers, more the merrier. 2-bucket toilet. Toilet seat, clips on the bucket. Toilet paper, sawdust for your poop. 4-in-1 gas shutoff tool. Thank you. Water shutoff on the bottom, gas shutoff on top. If you turn off your gas, you leave it off and let the pros turn it back on.
Shutting off your gas can be crucial to stopping fires. If you smell gas in your home after an earthquake, Mark suggests grabbing your 4-in-1 tool and simply turning the valve to the off position. It's easy to feel discouraged or overwhelmed when thinking about preparing for a disaster as large as the big one. But I think we could all take a page out of Mark's book.
The time to figure out what to do is not after the earthquake, the flood, the fire, but to know in advance if those things happen, what should we do?
You don't have to join a local emergency team, although it's great if you do, but just taking small steps today to start your preparation, like picking up a gallon of water or a few extra cans of soup for your pantry, can go a long way.
People will want to help and will step up to help to the best of their abilities. That's what everything shows will happen and what has happened in the past. And we can expect that's what's going to happen should we need it in Portland.
This is a graveyard. These trees mark the site of a massively destructive natural disaster. One that this region is due for again soon. Long ago, here in the Pacific Northwest, a giant earthquake struck the Cascadia Fault, a seismically active tectonic plate boundary off the coast. Almost instantly, the landscape dropped by 5 or 6 feet, unleashing a powerful tsunami. This wall of water and sediment covered huge swaths of land, leaving behind these drowned, dead trees as a mark of its earth-shattering power.
This was hundreds of years ago, but it might surprise you that we know exactly when this happened. 9 p.m. Pacific Standard Time on January 26, 1700. It was a Friday. This is a story about the clues buried in the trees, the soil, and even records kept by Japanese monks that scientists put together to solve the mystery of what happened here and when. How were they able to reconstruct one of the most violent disasters to ever hit North America?
Knowing this answer is important because this will happen again. But will we be ready?
If you're in a small boat and you go out at low tide, you can look up at buried landscapes below the modern high tide. When these great earthquakes happen, they either raise the landscape or they drop it suddenly.
That's David Yamaguchi. He was one of a handful of scientists who helped pinpoint the magnitude and date of the 1700 earthquake.
So this is the pre-1700 buried soil. Again, I don't know if you can see it on film, but I could feel it, and I can see it by eye.
Ocean tsunami waves are not just saltwater. They carry with them marine and coastal sediment that can both erode a landscape and lay down a new layer of soil.
Here we could probably see the individual sand layers from individual tsunami waves coming in over this subsided landscape. It's so obvious to visitors that something dramatic happened there to kill all those trees. The Copalis River Ghost Forest is the very best example that we have been able to find on the Washington coast of a landscape that has been lowered into the sea after a huge earthquake.
This area is a highly active tectonic region. Here along the Pacific Ring of Fire, the Juan de Fuca plate slips under and against the North American plate, squeezing and building up stress along the roughly 700-mile-long Cascadia Subduction Zone. Every several centuries, that energy is released in the form of large, violent earthquakes.
Until the end of the 20th century, the only evidence of past catastrophic earthquakes and tsunamis in the region were oral accounts from local tribes passed down through the generations. In the 1980s, though, researchers discovered some tantalizing clues indicating a massive earthquake that struck here in recent history.
One of those pioneers was this guy, geologist Brian Atwater. He began digging down into the layers of earth along the coast of Washington, searching for evidence of past earthquakes and tsunamis in the soil deposits that David was showing us earlier. What he saw was evidence that the land had dropped a lot, and in an alarmingly short time. He had a hunch something massive had happened here. But when? And more importantly, when might the next big one happen? Brian pulled in an unlikely ally in David Yamaguchi. David is a dendrochronologist, an expert in analyzing tree rings to construct ancient events. Brian had seen evidence of a colossal quake and tsunami in the soil, Could tree rings help narrow down when it happened?
If you have a modern tree and you know what the outermost ring date, you could determine when trees were killed by matching their ring width variation patterns against those of old living trees.
Brian found some nearby old-growth red cedar which weren't killed in the tsunami that David could compare to the rings of the dead trees in the ghost forest.
The outermost ring here is 1986, and it goes back through the centuries 1800, 1700, 1600, 1500, about 1430 on this end.
After comparing tree ring patterns in living trees with those in the ghost forest, along with radiocarbon dating, David closed in on when this Cascadia Megaquake happened.
Fairly quickly, I knew that probably we're looking at an event that was fairly soon after the 1680s or 90s.
Tribes throughout the Pacific Northwest have passed down stories about catastrophic events for generations, but because written language only arrived with European settlers in the late 1700s, there were no precise accounts or dates for these major events. Their next clue would come from an unexpected place thousands of miles across the ocean.
In 1993, Kenji Satake, who is a Japanese guy, learned about our work. And he said, if these Americans really did have a big coastal earthquake around AD 1700, it should have produced a tsunami wave that would have crossed the Pacific Ocean and hit Japan.
Coastal communities in Japan who felt those waves had detailed recorded history from that time and a calendar system that could be used to pinpoint exact times and dates. Kenji surfaced records of precisely when the tsunami hit Japan, then back-calculated how long it took to get there and pinpointed the exact timing of the event.
And so he published a paper saying, I believe that the Americans had a big earthquake and it happened on January 26, 1700 at 9 o'clock at night.
The soil, the trees, and the written stories across 5,000 miles and 300 years all pointed at the same theory: that a catastrophic quake was possible in the Pacific Northwest. And that threat still looms large for people that live here today. A modern quake along the Cascadia Subduction Zone will be catastrophic. Magnitude 8 or 9 shaking will level buildings and infrastructure. Major cities from Northern California to British Columbia will shake. Millions will lose power and access to clean water, and roads and bridges will become impassable. Tens of thousands of people along the coast will have as little as 15 minutes warning to get to high ground before a wall of water as high as 20 meters inundates the land, destroying everything in its path. The waves will keep coming for hours. How do we know this? Using past evidence, researchers have built models for what we can expect when the next one comes.
Surviving an event like that involves getting out of the path of the tsunami.
This is Carrie Garrison-Laney. She's a paleoseismologist and coastal hazards specialist who studies deposits from past tsunamis. This helps us understand modern tsunami hazards and supports the work of tsunami modelers like this guy, Christopher Moore from the Center for Tsunami Research at the Pacific Marine Laboratory.
There's a really great relationship between doing muddy paleoseismology work and work that's done modeling those processes. The NOAA Center for Tsunami Research helped to do the modeling that was used for the Washington State tsunami hazard maps, and that show the upper limit of tsunami inundation.
This is a simulation of the event that happened way back in 1700, this Cascadia Subduction Zone event. We weren't around to study it back then, so your work tells us whether this tsunami initial uplift is accurate or not, because you can look at those waves as they come along the shore and say, here there's a large wave along the coastline, but we don't see any tsunami deposit there. So then we can go back and say, oh, how do we modify our initial condition based on these measurements that you take?
Models like these are crucial for helping communities plan for tsunami evacuations and decide where to build critical infrastructure like hospitals, schools, and fire stations.
You've got multiple waves coming in. Even though it gets all the way into Puget Sound and it's lost some of its energy, it's not just one wave, it's wave after wave.
There is that big wave at the leading edge, but there's even a secondary wave and a third wave that comes several hours afterwards. We try our best to alert the public about the danger of going into the inundation zone before the waves have passed.
I mean, 6 hours after the event, a lot of people would think it's over.
Right?
It's possible that the 1700 quake was just one in a cluster of many earthquakes. So understanding the dynamics of how these events play out is crucial for preparing for future disasters.
We're gradually refining our models and they're getting more and more powerful. All of these things help us to understand what is coming.
Engineers and architects are starting to think of new ways to get tsunami escape towers up faster. The question is, do we have enough time to protect the coastal communities before the next tsunami hits?
Oh, there it is. Look at that. Wow.
More than 30 years after shedding light on the Cascadia Subduction Zone's potential for destruction, David Yamaguchi is visiting the nation's first vertical evacuation tower in Tokeland, Washington. The Shoalwater Bay Tribe's Auntie Lee Tower stands 50 feet tall and is anchored into the ground with 55-foot-long support piers. Shoalwater Bay Tribal Chairman Quentin Swanson has welcomed people from all over the world who, like David, are anxious to see progress being made to protect coastal residents.
We'll start by getting a look up top. So the idea is if you crammed everyone in like sardines, you'd be able to accommodate about 400 people. This serves as a beacon, if you will, of survival for everyone on the southern part of the peninsula.
Everyone, including tribal members
and non-tribal members as well. We have water, propane, electricity, heaters, as well as tarps to be able to run around the perimeter so that people can stay warm.
For me, it's just really cool to see this in person. I'm impressed.
The Shoalwater Bay Tribe is in the process of moving their village uphill to a tsunami-safe zone. They've acquired more than 4,000 acres of land, and the momentum is building, not just for this tribe, but for those who are witnessing their endeavors.
I've watched the community band together and want to help protect our village, to protect our people. It was the start of a movement. It made it feasible for people to start looking toward these alternatives to protect their communities.
In the meantime, this tower will be a lifeboat in a potential wave of destruction, and hopefully others along the coast can build more like it soon.
This is an incredible story about how geology and biology and history all came together to solve this mystery about a violent event in our Earth's past. And an incredible reminder of how many secret stories of Earth's history are buried under our feet.
What you do the instant an earthquake hits matters a lot. The right decision could save your life, but if you watch the first 100 videos on YouTube that capture the exact moment an earthquake hits, almost no one does the 3 things that authorities tell us to do: drop, cover, and hold on. So we're going to talk to one of the foremost experts on earthquakes in the world, Chris Goldfinger. In a previous episode, he helped us understand why the Cascadia Megaquake is likely to be the worst disaster in modern history. He told us he's not going to follow those recommendations either. Turns out Chris has been looking into where this idea came from, hoping to find studies that back it up.
But there wasn't scientific literature underlying that. That's kind of what got me started wondering how well that would work out in a real situation.
With the Cascadia Megathrust earthquake likely to hit the northwest US in the next handful of decades, and the San Andreas Fault keeping Californians worrying about earthquake danger, it's time to figure this out. So if you're one of nearly half of all US citizens who live in an earthquake-prone area, or the millions more globally, watch this episode because not all earthquakes are the same. Some earthquakes shake violently almost immediately, but others are created by very different forces, and depending on where you are, they can actually give a warning that you can feel. We're going to learn how you might identify that warning sign and what Chris plans to do if he's caught in an earthquake. Again, stay with us because near the end, we list the best and worst buildings to be inside, and you definitely want to know if you spend time in one of the worst ones. Okay, first off, magnitude 9 earthquakes are the strongest quakes on record. They're extremely rare, but cause absolute destruction. Think Sumatra in 2004, Tohoku, Japan in 2011, and the Cascadia Megaquake quake that's predicted to hit the Northwest US soon. They all have something in common. In addition to killing tens or hundreds of thousands of people, they are all subduction zone quakes, created when one tectonic plate is forced under another. That's extremely bad news if you live in a place that is overdue for one of these quakes, like the Pacific Northwest. But subduction zone earthquakes actually give us a warning because the vibrations they cause travel at different speeds.
So an earthquake generates about half a dozen different types of waves. P wave is just a pure pressure wave. It's like an acoustic pulse traveling through the earth. It travels a bit faster than all the other types of waves that are generated, and it's very light. You know, it's a very light shaking.
And that means the further away you are from the fault line when the big one hits, the more time between the P waves and the next, much more destructive shaking.
We're not going to feel the sharp snap and suddenly wind up over there on the ground and go, how did I get here? That's not going to happen. What we're going to feel is this minute of light P wave shaking where we're sitting there going, yeah, maybe that's an earthquake.
And that's crucial time you don't want to waste because most of the bridges in places like Portland and Seattle will collapse. Whole neighborhoods and industrial buildings that were built on liquefiable soil will slough into waterways. Landslides, oil spills, explosions, it's really an apocalyptic scenario. And what type of building you're in when the big one hits plays a big role in whether or not you survive.
1970, 1980 is really when we started understanding how to build structures in high seismic regions. However, we didn't actually discover the Cascadia Subduction Zone until 1988. So really in Oregon, we're concerned about any building that was built before the mid-90s.
If you exclude wood frame houses, 70% of the built infrastructure in West Coast US cities is not up to modern standards, meaning they might collapse. But where did this idea of drop, cover, and hold on come from?
What I found out when I started poking around was that it came from civil defense in the 1950s.
A turtle by the name of Bert, and Bert the turtle was very alert. When danger threatened him, he never got hurt. He knew just what to do. He ducked and covered.
And so we were trained as kids to get under our desks in case of nuclear attack during the Cold War. And along the way, that get under your desk concept was just transferred from nuclear attack to just multi-hazard. So now it's taught universally as the protective action for earthquakes.
And there has to be like a better way to stay safe during an earthquake.
In 2011, Chris was at an earthquake conference in an earthquake-ready building in Japan when the most recent magnitude 9 quake hit. So he actually got to feel the warning of the P waves. They were so subtle that the image stabilizer on the camera filming the presentation actually canceled them out. But then the larger waves hit.
And then one of the Japanese graduate students said, I think we should go outside. And we all followed him outside. So then we watched the building swaying and the flagpole swinging and all of this stuff.
That was a subduction zone earthquake. Now let's look at a video of a near crust earthquake. You can see people start to feel shaking, and within a few seconds, things are falling off the walls. Chris told us that if you don't have time to react, it's probably a near crust quake, and the best action might be to duck and cover. But what if you do have time? Most cities in the Northwest US are far back from the coast and the subduction zone, which means they'll be given a warning before the major shaking starts.
So we're 100 kilometers back from the subduction zone, which like where I was in Japan, means that I have a I have a full minute of light P wave shaking before the S waves, the damaging waves, get to Corvallis. So a minimum of about a minute. And so I started thinking, well, a minute's a long time, and what if the door was right there? Maybe I should just stroll out the door. So this one is the geology building. That's where my office is now. It's the typical kind of building that pancake collapses, in an earthquake. I'm close to the door on the bottom floor, and that was on purpose. So getting out of this one is no problem at all. I just walk right out.
And looking at videos of buildings collapsing, it's pretty easy to understand why people choose to evacuate rather than drop cover and hold on. But leaving a building during an earthquake, especially after the P waves hit, is risky too.
The deciding factor for whether to evacuate or duck cover and hold is situational awareness. First, should you run out of the building, or will you just be safer drop covering and holding in the building you're already in? Secondly, where are you running to? If you're running out of a building into the street where there's a lot of unreinforced masonry buildings, that could be potentially more dangerous than drop cover and hold.
So how do you decide what you should do? Well, one of the first parts of situational awareness is knowing what kind of building you're in. We spoke to Erica about 3 common building types and how each will fare during an earthquake. The best case scenario is that an earthquake happens at night because most people will be at home, in bed, and single-family stick-built homes are actually pretty safe.
They are very flexible, and so there are very specific details that we're concerned about as it pertains to life safety. Our chimneys, we're concerned about bookshelves, we're concerned about overhead light fixtures that could fall, and we're concerned about porches.
Because falling objects are the major concern in homes, ducking and covering might be the safest thing to do. That said, most homes aren't bolted to their foundation, so while you'll probably survive, your home might not. Next, we have non-ductile concrete buildings. Ductile means that something is able to deform without losing its strength.
Concrete is not ductile by nature. It is very brittle. It's like glass. It will fail suddenly. We would see crushing of the concrete at the base of our columns. We would see damage at the joints between our beams and our columns.
And all that could add up to the building collapsing.
The most dangerous buildings that we're concerned about are the unreinforced masonry building. All of the timber framing for the floors are pocketed into the masonry wall. So there's no mechanical connection. So as the building shakes back and forth, the two will separate. The wall will fall usually outwards onto the street. There's nothing holding up the floors itself, and those will collapse.
And there are a lot of these unreinforced masonry buildings, or URMs for short, in our cities. Portland has a map of all of its URMs, so make sure to look up your building if you have any doubts. The safest buildings were built since the mid-90s or have been retrofitted to withstand an earthquake.
A lot of these modern buildings that are located in high seismic regions are going to perform really well in an earthquake. And we're going to see that people can drop, cover, and hold and not evacuate. And we are slowly retrofitting our older infrastructure. And we've seen in these other earthquakes that those retrofits work. So we are in a building that was originally built in the late 1800s. And it was originally an unreinforced masonry building, but we can tell that this building has been retrofitted because we can see the steel framing members. We can see the steel columns and beams and girders and slab on metal deck, and we can see the reinforced concrete shear walls that are tied into the existing masonry facade. So if I'm around when the earthquake happens here in Oregon, this classroom would be a great place to be in. There's lots of desks to drop, cover, and hold onto for the students and for myself, as well as just being in a modern building that has been retrofitted for an earthquake like the Cascadia Subduction Zone.
And that's why in countries like Mexico, authorities direct people to evacuate if they are on lower floors of buildings. And in Israel, newly built schools are teaching duck, cover, and hold on, while students in older buildings are being taught to evacuate. Situational awareness really comes into play if you're on the coast, because there, you're not only facing the earthquake, which will destroy buildings and bridges just like in cities, but a giant tsunami will follow right behind. Knowing where high ground is and what obstacles might stand in the way could save your life.
But I think humans are pretty smart. We are capable of learning complicated things. And learning about what to do in an earthquake is far easier than learning about how to drive a car. You know, you have to learn how to drive a car properly or you may not survive. And I think people have to learn how to deal with earthquakes, or we may not survive either.
So what do you think? Is it worth exploring more complicated messaging that includes situational awareness in our earthquake survival recommendations? Do you have a plan for when the big one hits? Let us know in the comments, and as always, stay safe.